Okay, so I'm going to start with number 4. A jar contains 2 red and 5 green marbles. A marble is drawn, its color noted, and put back into the jar. This process is repeated a total of 4 times. What is the probability that you select exactly 3 green marbles? All right, so does this sound like conditional probability? No, I don't really think so. Does it sound like I can read through that, set up one little fraction, be done with it, and move on? No, sounds like I'm totally going to have to do some stuff here, right? How many events are happening? 4, because the process is repeated a total of 4 times. Are these events that are happening, are they independent or dependent? Independent because it gets put back in the jar, right? Now what I want is the probability that I get exactly 3 green marbles. And then here I've got 2 red and 5 green, so that's a total of 7. So the probability that I get 1 green marble is what? 5 out of 7. Then the probability I get another green marble is 5 out of 7. And then another one, 5 out of 7. Right. And so can I only care about 3 green marbles. Can I stop here, use those numbers, and be done? No, because that would be the probability of getting 3 green ones on my first 3 tries, or just 3 tries or something like that. So there's 3 green ones. If the 4th one can't be green, it has to be what? Red, so that means it would be 2 out of 7. Now that's kind of set up like I draw green, draw green, draw green, draw red. What if I drew the red one first? Would it change my answer? No, because I can multiply in any order, so the order doesn't matter, and I could have put the red one first or what, it doesn't matter. I multiply all these together. I'm going to go ahead and just give you the answer because I didn't let you get the calculators. And it is 250 over 2401, and it doesn't reduce. Everybody okay with that? All right. Number 5. The band at Vilsdale High School has 50 members, and the student council has 20 members. 5 student council members were also in the band. Suppose that a student is randomly selected. This should be from. I really thought I fixed all my mistakes, but I never did. From these 2 groups, find the probability that the student is a member of the band if you know that he or she is on the student council. Okay, so does this sound like conditional probability? Yes, it is. So I'm looking for the probability that the student is in band given that they are in student council. Okay. Now, when you have conditional probability, your sample set reduces, right? And that's important to remember so you can remember what goes on the bottom of things. But you're also kind of narrowing things down. So we can get this. We don't have to force this through the formula. We can reason through here and come up with the answer. And that may not make sense to all of you, so I'm going to show you a different way too. But it says what we know is that they're in student council. And so there are 20 student council members. How many of those people are in band? 5. So the chance, knowing that they're in student council, the probability that they're in band is going to be 5 out of 20. You with me on that? Now, you may not have been able to reason through that on your own, and maybe that really just doesn't even still make any sense to you, but I'm going to show you how to kind of put your information down. You may not love Venn diagrams. They're not necessarily my favorite. For some people, it's their go-to thing. It's not really, Venn diagrams aren't my go-to things for most of stuff, but this type of stuff, it's very basic, and I think it really does help make it make a whole lot of sense. So if I have these 2 overlapping things, it's just a very basic 2-circle Venn diagram. Those are not confusing. It's the more complicated ones that just are yucky sometimes. And so if I say that this circle represents band, this one represents student council, then the overlap of those 2 organizations is 5 students. So then what number goes here? There's 20 in student council, but this is not 20. What would this be? 15. And then this number right here would be what for the band? 45. Everybody okay on where those numbers came from? This right here is also very helpful if we don't need the total to get our answer, but if I needed the total number of students we were talking about, if you can organize it that way, it's much easier for it to make sense because the answer is not 70. I don't get to just add 50 and 20 because 5 of those kids overlap. Does that make sense to you? So you can't count them twice. But here, if I add 45 and 5, I get 50. Add another 15, that's 65. So it's actually a total of 65 students. So if you can reason through how to put that in there, then you can add them all up. That's your total number of students. We don't actually need it, but you might for something else. Okay, so now we look at our conditional probability thing. What is it that we know? Do we know band or do we know student council? We know they're in student council. So I can come over here. This is the only thing I'm concerned with is this circle. The kids that are only in band don't apply anymore because I know they're in that circle. So now I've narrowed it down to that. So the probability that in that set of people, the student is in band, that's where I get my 5. It's not out of 15 because I got to add them together. It's 5 out of 20, which is 1/4. Does that help? I'm not saying you have to do a Venn diagram. It may totally make sense to you without one, right? But that is one way to make it visually make sense to you. Okay, does that help a little bit? All right, so let's look at 6. The probability that a student studies and passes a math test is 17 out of 20. If the probability that the student studies is 15 out of 16, what is the probability that the student passes the math test given the student studied? All right, so is this conditional probability? Yes, it is. So the probability of they passed given that they studied. So based on this information, do you think that you could read through this and reason through it and then kind of come up with the answer without the formula? No. In this case, you don't have enough information to do that. So this is one of the times where you need that formula. I could have used it on the last one. It would have made it harder, but I could have. But here, I need it because that makes this the probability that they studied and passed over the probability that they studied. I don't have enough information to not use this, right? So then I just plug it in, and I know the probability that they studied and passed, that's this right here, 17 out of 20. Over the probability that they studied, which is 15 out of 16. Everybody okay with where all the numbers came from? Okay. Now please stop messing up on the fraction stuff. There are still some people that have no clue what to do past here. Or they think they do and they totally make stuff up. It's the same thing every time. The numerator is 17 out of 20. When you divide by a fraction, you multiply by the reciprocal, so you flip and multiply 16 over 15. You don't just multiply the fractions because multiplication and division are two completely different operations. Now, in this case, if we don't have a calculator, my suggestion would not be to just multiply straight across. You can, but that's going to make your life a whole lot harder. Can you reduce vertically? Here. No. Here? No. Can I reduce this way? No. Can I reduce this way? Yes. So these are both divisible by 4. 4 goes into 25 times, goes into 16 4 times. Now, can I reduce any more anywhere else? No. Now that it's reduced all the way, I'm going to multiply. So when I multiply straight across, I need to multiply 4 times 17. And I said, what is that? Second period, and I got crickets. And then I said, let's do 2 times 17. Crickets. Right? So let me tell you what's going on in my brain, and that may not be crickets in here, but still, the whole 2 times 17 thing, that used to be something that kind of stumped me a little bit. Like I'd have to think about it before I did it. But I found a way that I processed it so often the same way that I don't really have to think about it anymore. I think my brain still goes through that process. It's just a lot faster, so I'm not even realizing I'm doing it. But 2 times 17, 2 times 15 is 30, right? And then you got 2 left over, and 2 times 2 is 4. So 2 times 17 is 34. You with me on that? And there's other ways to do it. We'll talk about that too. But I know then that 2 times 17 is 34. But that process happens a whole lot faster because I continually did it. Then I have to multiply it by 2 again. Well, doubling 34 is easy. It's just 68. Now, of course, another way to think about it, which is another way that I show you often, is 4 times 10 is 40. 4 times 7 is 28. Then you add them and you get 68. Maybe you prefer that way because that way works even if it's not an even number. Whatever. Just find a way to be able to process that easily. And then 5 times 15. Well, you have 5 15-minute intervals. How many minutes is that? 75. Think in terms of time when it's 15, so I got 75. Now, since I reduced everything before I multiplied, I don't even have to waste a second deciding whether or not this reduces. Because it's the only reason that this right here would reduce is if something wasn't reduced right here, and I reduced it all. Now, 5 goes into 15 3 times. Could I have reduced that right there? No, because again, that makes no sense. And please, if you're one of those that stop doing that, it doesn't make any sense at all. This whole idea of number sense and understanding how to manipulate the numbers, That is really, truly what is holding some of you back. I know that may seem over dramatic, but it's the truth. And the more time you spend on trying to make those things process, the better off you're going to be. If I had a calculator, I would totally choose to use a calculator, not choose to do it by hand. Absolutely. If you had one, I would suggest you use the calculator so you don't mess it up. But if you always use it and you never exercise your brain, you're never going to get better at it. And if you just start doing it a little bit at a time, you will get better before you even realize it. Okay? All right. Any other questions on any of it? And if not, I have another one I want to work. But if you have a specific one, I'll talk about it. Anybody? All right. Then let's go ahead. Let's go back up to number 2 because I want to talk about that one. And then I will finish all of this after school. So number 2 says 3 cards with the numbers 2, 7, and 3 are taken from a box of 10 cards, each with a different integer on it from 1 to 10. What is the probability that the next card selected from the remaining cards will have an integer less than 5? So that last sentence pretty much said, what's the probability of you picking a card that is less than 5? However, there is more going on than that. And what this really is conditional probability. And you can reason through it a couple of different ways, but there's conditions set on that less than 5. It's not just less than 5 out of the 10, it's less than 5 given that 2, 7, and 3 have already been taken out. So it's the probability of it being less than 5 given that we've already pulled 2, 7, and 3. It's not just that simple right there. Now, you don't have to force this through the formula. You can. It would be kind of weird, but it would make it more difficult, but you can. But what would really, really help you be able to reason through this is to actually have the sample set written out. I know it's just the numbers 1 through 10. Those are pretty easy. You've known those for a really long time. But having them in front of you so you can think about, what's being marked out, what you're using, and whatnot is helpful. So we're going to write these down. All right, so what we know, what is given, is that 2, 7, and 3 are gone. They've already been pulled out. Then it says, from the remaining cards, an integer less than 5. So how many of the remaining have an integer less than 5? 2. So it's 2 out of a total of how many? 7, not 10, because it's out of the remaining cards. Once you narrow down the sample set, if it is a conditional probability, then your total sample set size reduces, and it's 2 out of the 7, not 2 out of the 10. Does that make sense to you? So just remember that if it's a conditional probability, you are reducing that sample size there. Okay. Any questions at all at this point? I got time for another one. All right. Then let's go ahead and go to another one that somebody asked me about earlier. I might as well go ahead and work it in here. Let's go to 11B. 11B. And I think the numbers actually make sense on this for once, so it should be pretty easy to find. So we want the probability that a point chosen at random in each figure lies in the shaded region. So we want the probability of the shaded region, right? That's going to be equal to, and this is an area thing, right? The area of the shaded region over the area of the whole thing. What's the shape of the whole thing? A square. So, because this is geometric probability, we have to use the area because we can't talk about an infinite number of points. So I need the area of the shaded region, I need the area of the square, and then I can set it up and move on from there. Okay, so to talk about the area of the shaded region, well, I'll just put SH. In order to find that, that's not a shape we know how to deal with, right? What are these little rounded things? It's a fourth of a circle, right? And we have 4 of them. So what does that come out to be? A whole circle, right? So the area of the shaded region is equal to the area of the square minus the area of the circle. You agree with that? Okay, so we'll start by finding the area of the square. Area of the square is s squared. What's the side length of the square? 16. So it's 16 squared, which is 256. So that's the area of the square. Then I need the area of the circle. That is pi r squared. What's the radius? 8. And 8 squared is 64. So this is 64 pi. So there are my pieces, right? The area of the shaded region then is the area of the square, which is 256, minus the area of the circle, which is 64 pi. Can I actually subtract those and change the numbers right now? No. That's the area of the shaded region. It's ugly, but it's the area of the shaded region. So that's what goes in my numerator. The denominator is the area of the square, which I already calculated. So now I can put all that together. So my probability is the probability of the shaded region, landing in the shaded region, is the area of the shaded region, which is 256 minus 64 pi. Ooh, how far were the right numbers? 64 pi over the area of the square, which is 256. Now I have to be able to reduce that. Can I just cancel the 256 out? No, absolutely not. Well, if I did, I'd get negative 64 pi. I don't think you could have a negative probability, and it can't be that big, so none of that makes any sense. But that's a big fat no. If you have more than one term, you have to make sure that you reduce out of every term. Either that, or really the true mathematical thing that you're supposed to do is factor the GCF out of the numerator, but I ain't got time to reteach you that for the 1,000th time, so we're going to go with it a different way. I have to be able to reduce all three of the numbers, right? Now, all three of them are even. So let's just cut all three of them in half. You have $2.56. You give me half of it. How much do you give me? 128. Minus, what's half of 64? 32. So minus 32 pi over 128. Oh, look, they're still all even. What's half of 128? 64. Half of 32 is 16. Over not over 128, over 64. Oh, look, they're all still even. 32 minus 8 pi over 32. Now, at this point, and before this, you could have found a bigger number that divided, but sometimes it's not worth the time trying to figure out if they all match. Just go with knocking it down some. I can keep going by twos. There's nothing wrong with that. But is 32 divisible by 8? Yes. So 8 goes into 32 how many times? 4. 8 goes into 8 once, so that's just minus pi over 4 on the bottom. And this is my probability right here. Does that make sense to you? See how to reduce that?